Wednesday afternoon, and I posted that episode 7 on Sunday. I was hoping to get this done on Monday, but as these things always happen, a few little bugs intervened and had to get them ironed out and a few other things. But now the wiring on the first staging yard throat is all complete, and it's all done. And here you can see from the back side, I'll talk a little bit, explain what's going on here. Here's the control panel, and I've got all these wires bundled, and I mentioned I was going to do generous loops in case I ever have to pull that panel out, so I have slack to pull it out and work on it. I hope not, but you never know. And then to explain what's going on here, as I said, we've got three kinds of power coming in here. The first is the digital command and control power for running the trains themselves, and that's approximately 18 volts AC. It's completely different, isolated, and I'll talk about DCC in another episode because it's the really the predominant technology now for controlling trains. Then over here, I've got these two capacitive discharge units that are being fed 16 volts AC. They put out approximately 12 volts DC, and they power the switch machines. I'll talk about those switch machines in a minute. And then I've also got 12 volt DC coming in, and that powers these double pole, double throw, single coil power relays that are in here. And I'll talk about these. And it also provides power for the LED indicator lights to show which track is powered. Now, to explain a little bit of what we've got here, the switch machines, or these are actually made in Britain. The Brits call them point motors because in British railroad lexicon and European railroad lexicon, what we call a switch or a turnout, they call points. What we use the term points for is to refer to the movable sections of rail on the turnouts. These are point motors, and they're really good. They're very powerful. They're made in England by a company named Gauge Master, and they have a number of features about them, and you'll see a graphic come up here that'll show about the features. But they're a latching relay. They have two magnets, meaning that when they're energized in one direction, they throw in that direction, they stay in that direction. And they have additional contacts that allow you to power things. And again, this is all highlighted on the graphics, and I'm using those contacts in addition to this. But you have a common coming in here on terminal C, and then depending on whether you energize A or B, depends on which way the turnout throws, which way the switch machine throws. And one of the reasons we use capacitive discharge units is you want a really good voltage into this to make sure it's a good positive throw. And the capacitive discharge unit hits it with a good sharp kick to make sure it throws all the way. And when these switch machines or point-out motors throw, the additional contacts wired in here go over to these power relays, okay? And they also are routed from the power relays to the LED indicators. Now the power relays are not latching relays. They're single coil relays, and there's a graphic coming up here. It'll show you what they look like close up. But they're a non-latching relay, so when there's no current going into them, they throw to one side, to two contacts, which allows you to power two contacts off of it. When they're energized, it throws to the other contacts, and this is what forms the logic circuit that allows each of these relays to exclusively power one track, and only one track at any one time will be powered depending on how I line the switches out here, and I'll demonstrate that in another segment to show you how that works. And the LEDs show me which track is actually energized. Now these are 12 volt relays. They operate on 12 volt DC, but they can handle 250 volts AC at 10 amps. So they're really kind of overkill for what I'm doing, but I got a really good price on them at Amazon, and they cost me about $1 a piece, and so it worked out really, really handy. So I got a bunch of these, and they go in these bases here. So all you have to do is you mount the base, and you do all your wiring on the terminals on the base. And again, that's in the graphic also. And then once you get the wiring all in and do your continuity test, you just take the relay and plug it into the base, and you're ready to go. So these are all plugged into the bases. And again, the wires also go from here. So when these switch machines over here are thrown and a particular contact is energized, the particular relay will throw and energize that track. Depending, again, I've set it up in a logic circuit so that a train can only proceed through if all of the switches turnouts are aligned for its track. So the track can only be powered when the switches are aligned, so the train can only move through. It's a simple interlocking system, but it avoids some real problems with the trains. Now, some of the things that I get when you do something, you can see this is pretty complex wiring. I've used color-coded wiring. Black, red, various sizes, striped, non-striped, but I've got a code system so I know what goes where. But even with that, you're bound to misconnect something. And that's just something you have to recognize is going on. So you have to debug this, and that was what was taking me time at the last couple days to get this worked out. And I got down to one problem I couldn't get ironed out, and I finally figured out it was the base on this number 3 relay for the number 3 track had a bad contact in it. So I replaced the base and everything worked well, but you have to work your way down to that point and step your way along the circuit, figure out what is not working here. And what really told me something was not working is that power was coming into the relay, okay, for switching, but it wasn't coming out. And I figured, wait a minute, there's got to be something either wrong with the relay or wrong with the mounting base. Turned out it was the mounting base, and everything's working fine now. Now, to test this, I've actually just putting straight old 12 volts DC in here where the DCC signal would go, but that's just to provide current so I can see what's going on, so I can make sure the tracks are being energized. So this with these wires here are just a temporary arrangement. But to save your sanity in working on these things, and it can drive you nuts, I've got some tools to recommend to you here. This is a continuity tester. And this is a very handy tool to have. $5-6 on Amazon, real cheap. And essentially it's just an alligator clip and an LED bulb and a probe. And you don't use it on an energized circuit. You just take all the power off the circuit. But you clip this from where you say one point you want to measure from. It's an alligator clip, you just squeeze it and it'll clamp onto it. At the start of the circuit, and then you can use your probe at various terminals along the circuit to make sure that you've got a solid connection. It's a continuity tester. This will, $5-6 is a good way to preserve your sanity. Again, Amazon Prime's got them, very inexpensive. A Sperry continuity tester. Now, another tool that you will find very handy, and this you can get at Amazon Prime or you can get at your local Home Depot. I think I bought mine at Home Depot. This is a multimeter made by General Electric. I think this was like $12, $15, something like that. But you can measure AC or DC, you can measure resistance. Very handy thing to have. A very good tool, and you will need one of these. And this was one of the ways this came in handy is to make sure I had a good connection when I had everything up and running and energy coming in. I could put the two polarized probes across the terminals, and this would read out the voltage I'm getting. So the power supply in here is 13.7 volts, the DC power supply. I'm tracing it through all the circuits, and when I got 13.7 volts out of the respective circuits here, I knew I had a good connection. Again, very handy tool, very inexpensive. Now, this next tool gets a little expensive, but it's handy. This is an Arrow wire staple gun. It's not like your normal staple gun. If you can see, there's a U-shaped notch here in the front, right there. You can see it, and it uses wire staples, which you can see here have a U shape. You can see that on the end there. Okay, you should not use a regular staple gun to staple down wires, but the nice thing about these, you can fire these wire staples in, and they give you a little arch that you can pass wires through. It's very handy. As you can see, I've got them throughout here, and it's great for organizing your wires and keeping them out of the way and making sure they don't get snagged on things. Another thing you'll use a lot of, just by the way, are nylon zip ties for cables. Real cheap, Home Depot. This you can get through Amazon Prime, not inexpensive. It was about $35, $40, but it's a handy tool. And you can use it around the house for a lot more than just model railroad applications. So strongly recommend you consider getting a wire stapler. Finally, this is a wire stripper, and it was a wire cutter, wire stripper that I got through Amazon. It was recommended in Model Railroader. I don't even remember the brand name. It doesn't even have the brand name marked on it. Oh, KYP wire stripper. The nice thing about it is you can strip any size wire, and it just grabs the wire. You can see it here. It'll grab the wire, the jaws come down as you squeeze it, and then it strips it off. Again, a very handy tool to have. So with that, I'm going to turn this around so you can see the top side, so you can actually see it in operation, and you can see what we've actually got here for a staging yard throat. And that was the underside with all of the wiring, and that is done. Now, one final note about that too. The next time that I do this, when the other throat, now I figured out all the things I can do wrong. The other yard throat ought to go through much more quickly than this. So with that, we'll take a break. I'll reshuffle things and I'll show you how it works. Okay, it's a few days on. I got a little delayed, a couple of minor details I wanted to work out before I did this part. And you can see this is all finished. I've got it turned up on edge so the track side is facing you so you can see how it operates. And I have power applied to it to operate the switch machines and to test all the circuits. And I'm happy to report everything is working. The control panel is working. And this is one end of the staging yard, the yard throat. Again, I have a second one to build, but hopefully it'll go a lot quicker now that I've figured out how I'm going to do some things and save myself a lot of backing up and starting over on stuff. But just to explain how it works, here's the control panel. Each one of the red buttons indicates a route selection here, and you can probably see this green LED indicator right here is illuminated, which indicates that this is a track receiving power. Now suppose I wanted to pull a train into track number 9, which is the top one here, the numbered 1 through 9, bottom to top. Okay, and this will also be the run-through track number 1. So I'll have a possibility of storing 8 trains, possibly 9 trains if I wanted to occupy all the tracks, but if I wanted to have a constant run-through track, I'll be able to use track number 1, or actually any one of the tracks, but operating practice, I'll go with number 1. And also, when the staging yard is set up, one of the things you have to have with a digital command control system is something called a programming track. And that's where you set various settings on each locomotive's receiver. These are called control variables, so that you can do speed matching and a bunch of other functions. And the programming track has to be isolated or isolatable from the rest of the layout, because if you start programming a locomotive on the layout and you don't isolate it, sometimes you can change all the settings in all the locomotives, and you really don't want to do that unless you want to go back and redo all your mistakes. So I'm going to set up track number 1 to also function as a programming track, which means it'll have some differences in how it gets power. I'll be able to select it for normal operation or for a programming track. But suppose I want to route a train through track number 1. Track number 5 is now the one that is getting power. So the first thing is go through the route selection here. So I'm going to flip this switch. Here's the lead for track number 5. Okay, and here as it sweeps around, this is track number 1. So I've got to start throwing some switches. Now right now this switch is set to run trains to track number 5. So first I have to do this route selection. You probably heard that good loud snap. Okay, that's what the capacitive discharge unit gives you. Okay, and when it gives it a good solid throw of the switch, so you're sure that it's set properly, the train won't hang up on it. Now I want to continue, so I can notice that the green indicator hopped down here to track number 3, telling me that switches are aligned to send the train on track number 3, but I want to go to track number 1. So again, I hit this and you heard another snap, and you notice that track number 1's green LED is illuminated, and I have over here test terminals that I've set up for each one of these tracks, and I've got my handy multimeter, and when I touch the terminals for track number 1, my multimeter, let me get the terminal set up here properly. My multimeter is reading 13.7 volts, which is the test current I've got flowing through there. So that tells me that track number 1 is energized, and trains can move on track number 1. They can't move on any one of the other tracks. Now the same function will be set up on the other yard throat. So actually I'll be able to have 2 tracks energized, but if 2 tracks are energized, it'll only be for entry from the particular yard throat that selected that track. So this would be a situation where I'd want to run a train out of, say, track number 9 and out of track number 1 going in opposite directions to meet somewhere on the layout. Which means that when the train coming out of track number 1 comes around, it's either going to occupy track number 9 when it pulls in the staging yard, or I'll have to select whatever track I want it to go into. But say I want to go into track number 2, basically just go select, change this routing. Okay, hear that snap, and then this turnout. Okay, track number 2's indicator is illuminated, and to do the test, when I put the meter on track number 2's terminal, it shows me 13.7 volts throwing through it, and on track number 1, 0. So track number 1 is dead, track number 3 is dead, and if you went all the way up the line, you'll notice that current was only flowing to track number 2. So that is how I wired the staging yard. Built this. It's an interesting experience, learned a lot. The next video I hope to do is to complete the Union Pacific staging or station project, and then I want to do the video about some of my favorite locomotives, and we'll get back on the staging yard. Just to tell you, the next part of the staging yard will be putting this aside for a moment and setting up the main layout base for the staging yard tracks. There'll be 9 of them, and it goes in an L shape, and that'll be the base point for my geometry for the rest of the layout. So aligning those bases properly will determine how this all fits together, and then the layout will expand from there. And hopefully by the end of the summer, I hope, the staging yard will be done, and I will start to wire in the DCC system, which actually some of that will have to start when I start putting in the base for the staging yard. And then I'll be able to start laying the first track of the main line around the layout to complete the loop, which should be pretty interesting because I'm going to be experimenting with some other techniques there, including spline roadbed. So that's the end of this episode, and hopefully I'll have it posted in a day or so, and then we can finish up the Union Pacific Station project pretty quickly after that. Have a great day.